Okay, so now we're going to look at the power of a power property. So, power of a power. Power of a power, I'm going to switch to a brighter color, that's not showing up too good. Power of a power, what we have is a power of m, and then that power of m is raised to an exponent. So that's a power of a power. And we want to know, what does this equal? And again, I'm not just going to show you what it equals, I'm going to explain to you why it is what it is by looking at an example. So we'll choose some random base again, like 3, and we'll raise 3 to some exponent like squared, and then we'll raise it to some other exponent like 4. Well, let's look at this. So we got something to the 4th, which means we've got it times itself times itself times itself, which is 3 squared times 3 squared times 3 squared times 3 squared. And 3 squared itself is a 3 times a 3 times another 3 squared, a 3 times a 3 times another 3 times a 3 times one last 3 times 3. So 3 squared to the 4th ends up being 1, 2, 3, 4, 5, 6, 7, 8 3's being multiplied, which we would express as 3 to the 8th. So take a look. 3 squared to the 4th. What would you do to 3 squared to the 4th to make it be 3 to the 8th? We would multiply that 2 and the 4. That's how we're going to get that 8. So a to the m to the n is a to the mn. Can I get an mn, everyone? I hope you're silently laughing at that corny joke. So a to the m is a to the mn. That's what we do. We multiply the exponents. So if you have x to the 5th raised to the 2nd, you're just simply going to multiply those exponents together, and it's going to be x to the 10th. If you have 7 to the negative 2 to the 3, yes, that's going to be 7 to the negative 2 times 3, 7 to the negative 6. And yes, that negative exponent property still applies. We could write this as 1 over 7 to the 6th. So that's our last power property, which is power of a power. You multiply. So, one last thing I want to mention before we get into some examples with this stuff is you're going to have to keep this straight. That if you have a to the m times a to the n versus a to the m over a to the m, and a to the m to the n, you have to know how these all work. If you have a set of powers being multiplied, the base stays, the exponents get added. If you have 2 being divided, the base stays, and you have the numerator's exponent minus the denominator's exponent, a to the m minus n. And if you have a to the m to the n, that's a to the m times n. It would probably suit you well to have these written on a little card somewhere, or write them in the margin of your paper. Sorry, our smoke detector's going off. And dinner's ready, but sorry everyone. But it probably wouldn't hurt to have those on a note card so you could reference them as you're doing problems.